Hello, SAT prep fans. This is Mr. Chu. Let's work on our SAT review video that has three problems on it from Module 4. This is my video 6 and 4, problem 16, 17, and 18. So remember, I have three modules already completed, 1, 2, and 3, that are in my playlist. They each have a total of 27 problems in each module, and there's 2 to 4 problems on each video. You can click on those playlists and review for your test. These practice problems are released by the College Board for SAT review. Some of the problems are going to be really easy for you, but some may be a little harder. They require background knowledge in algebra, geometry, and the other math classes you're taking in your high school preparation for the SAT. Topics vary from question to question. I do not have them in topic. The questions just come in the order of the module. Make sure you like this video and follow me on TikTok, Instagram, Facebook, and X. I have more helpful videos and I've got lots of things planned to help math students. So while you go to my YouTube, go ahead and subscribe. Here's the long link. There are also links in various places you can click on to subscribe, but you can also type that long link in the browser. If you need to get on me, I have an email address, askmrchu@gmail.com. Let's get started with these problems. Always pause these problems if you need to work them on a piece of paper to see if you understand how to do them, and maybe you can have them done and quickly move on to the next problem and just check out the answer. The function f of x equals 206 times the 1.04 to the x power models the value in dollars of a certain bank account by the end of each year from 1957 through 1972, where x is the number of years from 1957. Which of the following is the best interpretation of f of 5? And it says f of 5 is approximately equal to 243 in the context. So, first of all, you have to think, what kind of a function is this? Well, it is exponential growth. We're given that function. The 206 has a meaning. The 1.034 has a meaning. This x, it's already told you, it's years from 1957. To find f of 5, I just substitute a 5 for the x. So f of 5 equals 206 times 1.034 to the fifth power, which represents the value of the bank account 5 years after 1957 to 1962. Now, let's just go ahead and talk about what that 206 means. That's the amount of money that they deposited in the account when they first opened it. The 1.034 means that it was going to earn 3.4% annual percentage rate. And you put a 5 where the X is, which means 5 years after 1957. So that would mean that it would go from 57 to 62. So when I plug that in now, I have to do this exponent first based on the order of operations. So it's going to be 206 times 1.1819597. I just listed all of the digits that came up on the calculator there. And so when I multiply that by 206, I get 243.4872. In 1962, the value of the bank account was about 243. It was about $243.50, 48 cents actually. And so if you look at your choices, choice B is the only one that expresses that. It says the value is 243 in 1962, which is what we said was the case. A said it was $5. We know it's not that. That's not the case. C said it's 5 times greater. That's not the case. And D says it's 243 between 57 and 1972. And that 5 just means 5 years after 1957. So let's go on to number 17. Number 17, and remember to pause this and work it and see if you can get the right answer. For a certain rectangular region, the ratio of its length to its width is 35 to 10. If the width of the rectangular region increases by 7 units, how must length change to maintain this ratio? So we're going to have to write a ratio and end up writing two ratios to make a proportion. Then solve it and then analyze it and see if it's increasing, decreasing, and by how much. All right. So I can write the proportion the length to the width equals the 35 to the 10, and that was given. So when I cross multiply, which is how you solve these, I take my 10 times my length, which will be 10L, equals the 35 times the width, which is the, we cross multiplied there. So we just change the length for L, the width for W, cross multiply, and I get 10L equals 35W. Now I'm going to solve for L. So to solve for L, I use the division property of equality, division POE, divide both sides by 10, and 10 over 10 is 1, and 3.5 divided by 10, or 35 divided by 10 will be 3.5 W. So the length equals 3.5 W. That means that as W increases by 7, because it's what I said here, 7 units, L increases by X. So I replace L by L plus X, that's how much it increase, and W by W plus 7. So I'm going to rewrite that and then substitute L equals 3.5 W. So where the W is, or where the L is, I put 3.5 W. And for the L plus X, I added an X here, added a W plus 7 here. Now I'm going to use the distributive property right here. Distribute on the right. And for this L, I'm going to substitute a 3.5 W. Why? Because that's what we set up here on this line when we solve that. So the L plus X equals the 3.5 W. I'm just doing the distributive property where you take the number outside the parentheses, multiply it by the first term, and there I get my 3.5 W, and then take the number, multiply it by the second term. 3.5 times plus 7 is plus 24.5. Now I'm going to substitute L for the 3.5 W because I'm going to just solve for W because it says how must the length change to maintain the ratio. So I've got L plus X and this 3.5 W. I put the L in here. I'm solving for L, not for W. And I subtract L from both sides. Crosses out here, and X equals 24.5. For every 7 units increase in width, the length increases by 24.5, which is choice B. Now I knew it was going to increase, right? Going to increase. So I knew I could have ruled out A, and I could have ruled out B. I just had to find the amount, and this is how you find that amount. All right, hopefully you was able to understand that. I accidentally said solving for W, and we're really solving for X by canceling out that L right there. All right, so let's move on to the third problem in this video. Make sure you pause it if you need to. Work it on a piece of paper, see how much you know. Square P has a side length of X inches, where Q has a perimeter that is 176 inches greater than the perimeter of square P. The function f gives the area of square q in square inches. Which of the following defines f? It's here now. So I define a variable and write the function. So what's it ask you to do? It says let x equal the side length of square p. We're having to find it says, which of the following defines f? So we're having to say what x is. Well, x is the length of the square p. After I define that, now I can say that the perimeter of square p is going to be x plus x plus x plus x. And when I combine those, I get 4x. This makes sense. The perimeter of a square is going to be adding up all the sides. I know that the perimeter of square q is 176 inches greater than the perimeter of square p. So now I can say that I know that the perimeter of q is going to equal the 4x plus the 176 because it's greater than the perimeter of square p by 176 units. So to find each side of square q, I'm just going to divide by 4 because each side length has the same length. Every side will be the same length in a square. So I take my 4x plus 176 over 4, and I can find a common factor of 4x and 176 by reversing the distributive property up there. So it ends up being 4, and 4 over 4 is 1 and actually cancels at a common factor of 4. So I just get x plus 44 equaling the side length of square q. So then the area of any square is side squared. So I take the x plus 4 and say the area equals that quantity squared and substitute f of x for a to get the equation in function form, which is f of x equals x plus 44 quantity squared, which is choice A. Now, they could have made it a little harder and made you multiply that out. They just wanted to see if you could set that up and find the side length. So hopefully you was able to get that one right as well. All right, make sure you follow me on Facebook, TikTok, Instagram, X. I've got helpful math videos on there, and I also will be making announcements of what's coming. And I've got a whole curriculum that I'm writing right now. So all 27 problems in modules 1 and module 2 and module 3 are in my playlist on my YouTube channel. But in order to get to it, you need to get to my YouTube channel. And if you're going to get to my YouTube channel, I recommend that you subscribe because there's a lot of things that could help math students. So here's the long link to subscribe to that. I do have that email address, askmrchu@gmail.com. There are subscribe buttons at different places. There'll be one on the end screen, and there's usually one here on the corner. If you have any math questions, go ahead and send them to me. Spread the word. I have this math algebra curriculum called Bear Curriculum. I'm trying to develop it to help homeschool students and parents understand math better. I do have geometry videos that are called Brack Geometry. I have more basic math problems, which are pre-algebra and arithmetic, called Tray Arithmetic. I have math minutes, which are little snippets of just various random problems. I've got the essay test prep, and then I have another thing that I call math minis that I just started to do based on the math minutes. So I'll see you in this next video. Make sure you check it out. And remember, I'm Mr. Chu, and I want to help you understand math and prepare for the SAT. I'll see you in the next video.